Welcome to another episode of Code for Thought. With so much output on machine learning today, how can we evaluate and test the results they produce? How can we take a new algorithm and architecture into production? And how do we keep up with the constantly changing technologies involved? Meet Grigori Fursin, whose Collective Knowledge Framework, or CK Framework in short, aims to take some of the pain of doing all of this away. As Grigori says on his website, the framework helps to organize your software project as a database of reusable components. Well, very much like Lego bricks. And here now my conversation with Grigori. Hello, Grigori, and welcome to the show. Grigori, could you please introduce yourself quickly to the audience?
Hi, Peter. Thank you very much for having me. So my name is Grigori Fursin. Briefly, I'm trying to work on making machine learning more practical and easy to use in production. I spent many years in academia and industry working on this topic, and I think it will relate a lot to our discussion today.
You set up the Collective Knowledge Framework. Let's start our discussion with that. Could you explain to the audience what that is and what it's for?
My general interest for many years was to try to understand how machine learning, artificial intelligence works, and to make it easy to use it in the real world. It sounds relatively easy, but in fact, if you start working on that, it's extremely difficult. And that's why I started working on these topics 20 years ago, a really long time ago. And each time I had so many issues with trying to understand, like taking a paper and trying to understand how it works, reproduce it, and so on. It takes ages. Now we have 100,000 papers published every year. So it's actually really very difficult to actually navigate through all this. And at the same time, when I tried to move some of machine learning models to production, one of the biggest challenges what we faced was that systems are changing every day. So basically your research is getting outdated, you publish it and next day it's outdated. And it's extremely difficult to keep pace with all this continuous change. As a scientist, I actually didn't think about building my own frameworks just like really for this task. I was hoping that someone would do it for me, just like probably everyone else expects that, because I want to spend time on research. And eventually I realized that there is no tool which could help me to adapt to this continuous change in software and hardware. And I was spending probably 90% of my time not on research at the end, but really on struggling with all this. Okay, my TensorFlow version changed, API changed, my dataset changed. What do I do with all this mess? What's all this complexity? So I decided to build a tool, which I call Collective Knowledge Framework. And just very briefly, my idea behind it, two major ideas. One thing, I realized that one big part of machine learning is that you need to optimize it, and it's very time consuming. Mm-hmm. And when I started working on this 20 years ago, I didn't have so many cloud resources as you have now. So my idea was to have some kind of framework where I could distribute this optimization across many users, a bit like SETI Home when you look for extraterrestrial life. So now why not to do the similar thing for optimizing machine learning models? This is one thing. And second thing, when I tried even 10, 15 years ago to produce papers, I have realized that we have 100,000 papers and probably we'll have 100,000 scripts which would do exactly the same thing, installing packages, downloading some data sets, running some experiments, and so on. But they're all different. And if you want to understand how it works, you have to go through complex readmes. You have to spend lots of time. And if you have 100,000 papers, it's not scalable. So I thought about building a framework a bit like Lego, where you would have the same workflow, let's say, for image classification, object detection. But then everyone else, academia, industry, different people could start plugging in their own techniques. And it would magically work automatically. It would work across different platforms. It would run different experiments. And the idea of collective knowledge, why I call it collective knowledge, is that I wanted people not to, or researchers not to share their knowledge potentially just as a paper, but encode it in some form, like a bit microservices, where you can actually, everyone else can take it. It has an API, standard API. It has a meta description so that I can plug it in and start using it immediately. So that's why you encode this. Basically, it's kind of a collaborative framework for collaborative research. That's like a very high level idea behind this framework.
You said you wanted it to magically happen. Does it magically happen now during your framework?
We're getting close to that. So this framework, it's already fifth generation actually of framework which I'm building. when I started working on this project, on the original idea, it was 15 years ago. And each 2-3 years, once again, the idea was still what you said, like to do this old magic. But each 2-3 years, I solve one problem, and then like 2-3 more problems appear. I solve 2-3 more problems, and 10 problems appear. And that's why every 2-3-4 years, I was building a new framework. I think now we came very close to this understanding how we can make this plug and play approach. And I think it starts working. So the prototype is working. But once again, I would consider it as a stage of still of a prototype, which has a really good, successful use. But we need now, I'm already thinking about the next generation where it will be completely magically kind of plugging in everything together.
So you mentioned two main areas, the optimization of parameters in machine learning and then the ever-changing environment in which machine learning products run. So they're quite different areas. So how does the CK framework, if I use the abbreviation, how does that actually help you in that? I mean, what does it do to magically make that happen?
So very good questions. First of all, just a brief again, like description of those two areas. There are two major areas of research and development in machine learning at the moment. One is what we call machine learning training. And basically, that's where you are trying to build your model. You are trying to find hyperparameters and usually you focus on accuracy. So for last 10, 15 years, most of the focus of academia was about state-of-the-art accuracy, like improving, image classification, object detection. And there are lots of good tools to do this now on platforms. But then when as an end user, I want to use it in production, I want to take a trained model. And then you suddenly realize that you have completely different problems. It's not just accuracy, which you care about. You care about actually how fast is your model. Because if you're in a self-driving car, okay, you can perfectly predict that your pedestrian is in front of you. Fantastic. But what if you do it during 3 seconds? By the time of your prediction, unfortunately, bad things may happen. So you need to have like real-time constraints that the prediction is, within 50 milliseconds. The throughput that you can sustainably do predictions on many images or do speech recognition and so on. Power consumption. You cannot have, let's say in your self-driving car, a device which is, 200-300 watts, because you will spend all your energy on this device. Then if you start reducing your, you make models simpler so that you fit the constraints, then accuracy drops. And that's why when you move from training to actually production, you start having those multiple characteristics you have to tune at the same time. And what is worse, now imagine that you have now 4 or 5 characteristics which you have to tune. And at the same time, your systems are changing every day. So you have this crazy task. And that's why for the last 4, 5, 6 years, companies struggle really to actually, they understand how to train model well, but then how to move it to production and what is called now buzzword MLOps. How you actually bring it to production, how you start sustainably using it in production when the environment is changing, and how you continue optimizing it. So I'm working on this part. And just getting back how CK helps with that. Another idea of CK was to start that the community start sharing what we call automation recipes for different most commonly used tasks in machine learning.
Such as, for instance?
Such as, I want to use, once again, image classification, object detection. But maybe I want to run it with a slightly different framework, TensorFlow version or PyTorch version, maybe with a slightly different data set. So what I would do now, I would provide an automation recipe which would search automatically on your system which TensorFlow do you have. We'll return it back to you through an API and we'll tell you, a bit like a Lego brick, are you compatible with this framework? And you say yes or no. Again, you abstracted your system, so you now can say you write your own workflow which says, I can work with this system. Let's plug it in. Then it searches on your system another automation recipe and says, I want to connect a data set. Let's search what you have. And for now, over the past 2 years, I worked with different great companies and lots of work is public, where we started sharing those automation recipes for the most commonly used frameworks, TensorFlow, PyTorch, TVM, for data sets, for models, so that the more recipes we have, the system start adapting automatically to your environment. And that's how CK helps, that we provided this adaptation layer, which for now used to be hardwired. Now you hardwire your script on this specific TensorFlow version. Don't do it. Query CK, find an automation recipe, and this recipe will find compatible object which you need for you. That was the idea behind CK, how it can help. Actually, it's extremely difficult to do, and it's an immense acceleration of research. There is a public information, someone can look on the web, presentation from General Motors 2-3 years ago, where they described my framework and how it helps. And we show that this assembling of workflows automatic, it can speed you up your research by maybe 10-20x times, which is already immense itself. But it doesn't solve the second problem of optimization, which is yet another huge problem. Now, because I have also unified APIs, I can actually expose optimization parameters now. And optimization parameters, not just machine learning model parameters like hyperparameters.
Yeah.
It can be compile optimization, it can be hardware parameters, anything, whatever you want.
Okay, so because I was thinking about hyperparameters in particular, so you're thinking more
I'm thinking about the whole stack now.
Okay,
now
yeah.
That's what is cool, and this is again for the first time with the CK framework, because we're now covering the whole stack, not just machine learning model, but machine learning model, software and hardware. We can do this complete, what we call design space exploration of the whole stack, that's where you get the best optimizations. And now we expose all those parameters, and then we expose characteristics what we want to measure, which can be multiple: latency, throughput, power consumption, speed, size.
I'm still struggling a little bit, because if you say that the environments in which we run these models change constantly, what I'm struggling with is sort of how do we actually measure performance, and how can we actually compare performance output with all these different systems?
Very, very important question. Since we now have a unification we have a common workflow for a given task, and we can run it across potentially different software and hardware stacks, and we have the same APIs, it's still not a magic. Someone needs to provide the gluing between, let's say, different framework, different hardware, different software. CK itself, it provided you what I call a playground where we can understand together what is the common output, what we have, and how to compare it. So once again, it's not a magic. You need to have a common tool to do it. That's where I would like to introduce also ML Commons. So this is a non-profit organization which was created very recently. You have about 50 companies, all the major software and hardware vendors for machine learning, that came together to try to unify machine learning benchmarking, make it more comparable and reproducible. And I'm participating in this initiative. And actually right now, as I'm talking to you, we're discussing potentially using CK as one of the frameworks to make this unification. So once again, CK itself, it's not a magic. It's not providing necessarily like the final step, but it helps you unify systems, because I provided this automation.
Yeah, because it sometimes feels a little bit like black magic, doesn't it? I get the impression that sometimes people really don't know how to tune these parameters, and it feels a little bit like random walk.
I agree with you. And once again, that's why my idea of having a common framework where you can plug in different components and still someone has to provide this gluing was to gradually solve this issue. Because once again, imagine you have this black magic, someone is doing something. Then you have 100,000 papers. Each of this is a black box. So that's why we're lost. We have no idea what is happening. We have all those numbers, but you cannot just reproduce even 0.01% of all those papers. Having a common infrastructure, by the way, notice once again, I'm not necessarily completely solving all the reproducibility issues, because we will never solve reproducibility issues. Why? Because systems are changing. So each time we'll have some new issues appearing. It's normal, it's natural. But having a common framework means that the community have a common language to speak to each other, so that we can come up with better reproducibility. Again, not magic, it's a community effort.
So you mentioned this work group, and I would like to find out a little bit more the work that you're part of and what they're trying to accomplish. Can you tell us a little bit more about that?
Absolutely, and I'm very excited first of all, about this nonprofit organization, and I know the founders very well. 2, 3, 4 years ago, before this ML Commons nonprofit organization was created, every single hardware vendor which is producing hardware for not necessarily machine learning, but often for machine learning, they would publish their own benchmarks, their own results, and they say they're the best. And there is no independent, easy validation of those claims, first of all. And second of all, just what you said before, you cannot compare actually those numbers which are produced by hardware vendors between different vendors. Because once again, if your software stack changed, if your data set slightly changed, you usually don't see it in the press releases. It's like, we have this fantastic number, I don't know, it's 1000 FPS, whatever, our system works. But what is exact, like, what was your data set
What does it
used?
mean?
What was the framework? It's usually kind of hidden. They understood that it's time to come together to actually come up with a common methodology for comparing machine learning systems. For the last 2 years, they're working together as an open community effort, trying to come up with two things. First is a common methodology, so that we understand that we have apple-to-apple comparison. And second, with a tool, with a benchmark. It's called MLPerf benchmark, where you can plug in several frameworks for now, and you can run several tasks like image classification, object detection, speech recognition, NLP, and some new tasks are appearing.
So basically they identify some kind of basic use cases against which you run the benchmark.
That's correct. And again, it's a community effort. So it's a discussion within several work groups where different companies or even academic researchers say that, we think that this task is extremely important for everyone. And then everyone discusses, say, okay, let's add it to the system. And the idea is that whenever they publish results, those results are reproducible and comparable. Itself, fantastic idea. It works, but it's extremely difficult to build such kind of benchmark at the moment. It has to be scalable and extensible. And for now, it's not the case. And that's where I'm participating in several work groups there. It's very exciting work. We're discussing the ideas of potential like CK framework to be used to make this basically this plug and play interface so that it's much easier to add new benchmark, much easier to add new hardware, much easier to add new framework. It's not completed. I'm working with the best practices group, which is basically responsible for this. And we have another project, just lots to mention. We are trying to provide also standard. And this is some tool called MLCube. The idea is to provide some kind of high-level API for all those tasks, potentially with a container, and probably CK will be inside it. So it's a complete solution. You have both snapshots with the Docker, you have API, and then you have flexibility with my tools to plug in different components. It's an ongoing work, so there is still a lot to be done, and hopefully you will see much more work this fall and maybe next year.
You mentioned a submission before we started the interview, that you have a submission coming up. Can you tell us a little bit more about that? What's that about?
Sure.
How that fits in?
So once again, this benchmark it's an open initiative, and everyone can submit their own results for different tasks, for different models, for different hardware. And for us, I joined a very interesting company 4 or 5 months ago called Dr. ML. Which is basically also the mission is very similar to my mission. So we're trying to make it easier for end users to optimize and deploy machine learning. We're building a platform for this. At the same time, so they have a fantastic technology called TVM compiler, which basically try to automatically optimize machine learning models. And we're thinking about those workflows to make it easier to deploy machine learning. And what we're trying to do is that we're trying to do a few use cases based on CK now and on this TVM compiler with several of our partners. And we're trying to submit results showing that you can do it magically, just like on magic. Well, it's a joke, but the idea is that to make this fully automated end-to-end submission system, and that's what I'm collaborating with ML Commons, and we want to show that we can do it with CK, that everyone else, it's basically democratizing this process. And this will be fully free, fully open source. And we hope to connect it with academia and industry.
Well, good luck with that.
Thank you.
You mentioned the key thing here, sort of connecting academia and industry, because that's what I would like to discuss next a little bit. Because we think about machine learning as the sexy algorithms, that solve all our problems. But I think the deployment of them, the rolling out and productizing of them is quite a different task, as you already alluded to. I think there are quite a number of important lessons that you can learn from how to roll out a machine learning research project successfully into a product.
Yes, so let me tell you, first of all, like my real story, what happened to me.
Okay.
I was in academia in my previous life, and I really loved it. I had fantastic experience because you build new ideas, you prototype new ideas very quickly. You are not necessarily bounded with commercial interests, and that's how we came up with this idea of using machine learning to speed up auto tuning process, which is using machine learning. So it's kind of circle, and we published several really interesting papers in 2009, some years ago, which 10 years ago we were lucky to get Taste of Time Award for this. But then in 2009, after all this success in academia, I thought, okay, so now let me try to go to industry and test it in industry. It should be easy. And that's where I moved first to Intel Exascale Lab in 2010. It was a fantastic experience. But what I have realized, everything what I did in academia, the environment, the tools, everything is very different in industry. So I could not just take my stuff and apply it. And this was actually a shock for me because I thought it would be so easy. And besides, you as a researcher, you're very excited about what you're doing now. Like, okay, I will now solve everything. It's like, oops. What I realized that several key things, what happens, why the gap is growing between academia and industry. So in academia, very often, because you want to focus on your research idea, you usually fix your setup, everything. You fix a data set, which is usually like a standard data set. You fix your framework, you fix your hardware. Why? Because when you fix it, then you can start doing experiments for 2, 3, 4, 5 months. Then you spend 2, 3, 4, 5 months publishing a paper, and in a year you say, here's my cool paper. Ideas may be valid, may be good. But the problem is that in 1 year, everything have changed. And your results, maybe they are valid, maybe they were valid 1 year ago, but they be completely different with a new system, with a new environment, with a new data set. When you move to industry, it's an opposite extreme. You are bounded by your commercial interests, so you have to produce. You don't have so much time for research necessarily, so you have to produce good results on the current software and hardware. So you're maybe not thinking like 1, 2, 3 years ahead. And that's why you're also bounded because you don't know what will happen. And by the time you you optimize your solution on the specific hardware, software, in 2, 3 months, new hardware, software comes into play. So you again do the same thing and you repetitively continue doing the same thing. There's lots of waste of resources and time. These are two extremes and there is no easy solution in between. For me, I was still thinking that maybe we can solve it. And once again, how CK comes into play is that my idea after having this experience with academia, then trying to bring my technology to industry, was still to come up with this common workflow framework, with a common solution where both academia can use and industry can use. And what is very interesting is, on one hand, in academic circles, you can still do this quick prototyping, but then CK basically manages this adaptation to the system. So, and it works. So basically I'm testing my idea, my research idea, but in 2, 3 months or every, 2, 3 weeks, I can actually continue automatically testing my idea that is it still valid for the new software hardware? And you don't need to do any changes because that's what kills research. Because if I spend 1, 2, 3, 4 weeks adapting my stuff to a new software, I'm not doing research. And at the same time, when you publish your paper, it's not just a snapshot at Docker or Jupyter Notebook, but you can actually publish your paper with the CK workflow, which means that industry can pick it up and immediately test it with a different data set, with a different software, and with a different hardware, plug it in, potentially private. So I organized a competition at the SCM conference where we wanted to optimize image classification, but not for accuracy. There were many competitions about this, but actually in terms of speed, size, model size, and different characteristics, power. And the idea was that everyone could submit their own implementations of image classification, and we would test them, we would unify them so that you can compare make apple-to-apple comparison, and we would share a dashboard where you can actually check what is your speed, throughput, power. You could pick it up and reproduce results. And it was called Request. My co-organizers was the person who co-founded OctaML, so we're working together now.
Okay.
What happened there is that the point that when we had all those submissions, we converted everything into CK framework. So we had apple-to-apple comparison and we shared dashboard. Dashboard is still available 2, 3 years later.
Okay.
One of the submitters was from Intel, and they showed that they had a really fantastic result. We reproduced it. There were some issues, but once again, with a common framework, we could fix them, and we shared the result as a workflow. And 3 months later, colleagues from Amazon publicly, they sent us a message. They said, we picked up your workflow and we ran it on different systems, but we got similar result. And they invited us to make a big presentation, which we did 4 months later at the Intel O'Reilly conference with Amazon, where they showed how those workflows from academia can be used immediately in production. But that's why I believe that it can bridge the gap between academia and industry. Again, this common language.
Well, I've got a thousand questions now. One of them is, with 100,000 papers a year, and that's just for one area alone, reproducibility really becomes a huge task, doesn't it? And I think very often when people talk about reproducibility, it's they get the paper and maybe the data set and maybe the software. But as you mentioned, the software may not run because the system parameters have changed. So how can we make software, or in particular in machine learning, more reproducible? What does reproducibility actually mean in that context?
Wow, so there are many sub-questions in this question. So first of all, in terms of reproducibility in machine learning, once again, for me, a very important aspect of machine learning reproducibility is not that it's not anymore just accuracy, which we care about, but it's really all the numerous characteristics which we care about when we move machine learning to production. Latency, throughput, power consumption, size, not only of the model, but actually of the whole stack. So it's not just one characteristic, it's like thousands of characteristics, like a live system. When you think about all those characteristics, so when you publish your paper, the idea is that you somehow have not just to think that, people will reproduce like one characteristic. In fact, you may not even consider it as your research, but other people will be checking many other characteristics. If it's not a community effort, if you don't have a common tool, people will not have time to actually look at what you did, why you did it. They will go through your README. So for me, reproducibility is that, first of all, it's a moving target, because what I told you 10 years ago, it was like, let's look at accuracy. Afterwards, people cared a lot about latency, throughput. Now people care a lot about power. So reproducibility is a moving target. We need to kind of have all our methodology being adaptive. That's what we don't have. For 10, 15 years, I was participating in different kind of groups trying to solve reproducibility. And my concern now is that many people get together and say, we will now sit and for 6 months, we'll try to come up with the best rules. We'll cover everything. We'll provide the best tools, the best software, and it will solve all the reproducibility issues. That will never work. We have to have this kind of flexible media where actually community is trying to continuously solving those issues, encode them into what I did, like automation recipes, and it's each time we'll have new problems. We don't have to have a new commission sitting for 6 months trying to solve it. It has to be a community effort. That's why, so reproducibility, we have to care about multiple characteristics, not just accuracy. Second, we have to bring community on board. That's what ML Commons is doing, so that it's a dynamic process. To some extent, that's why I did CK. So for me, when I started hitting all those reproducibility issues, I tried to build those tools with those automation recipes where I wanted to encode every single fail of a system. If you now have a kind of this distributed system and people using the same framework, if you fail, what happens now? By the way, this is another thing. I'm sorry I'm diverting, but it's actually a very important point. When I do research and I publish papers, you publish only the best results. But your research, which you do for 6, 7, 8, 9 months, you have so many failures and so many, reproducibility issues. No one sees that. You actually skip that. For me, this is much more important than actually having your final best result, because this is actually what, if everyone from those 100,000 papers, we could see those issues, not like the best result, which is outdated, but we actually see all those issues which everyone experienced, and each of them record the solution, potentially in some kind of automation recipe, which everyone else can reuse. That's how we'll solve reproducibility issue.
I think we're coming now to the end of the recording, but I think there are a couple of questions, or at least one of them, which is the level of adaptation of your framework in the industry. You mentioned already, I think Intel, if I understood correctly, and others.
Couple of things. So Intel, this was my work, like kind of a previous framework, which I did some years ago, and then they participated in our tournament. CK framework is being used by some companies. If you look at ML Commons, who submitted results, who using CK framework, so there was Qualcomm, Dell, I think ARM at some point was using it. We collaborated very successfully with General Motors and with a few other companies. I have to admit that maybe being very shy or so on, I was building this framework first for myself. It turned out that when we worked with this framework, that it was useful for other companies and universities. That's why I wouldn't start speaking about like huge adoption of CK framework. I think it's a fantastic prototype, which I don't think there are any frameworks which are similar to that, but it's still far from being like ultra user-friendly, and so there is still a huge effort to be done.
So you think that it's on the way of becoming more user-friendly and more in terms of a product that people can adopt. Is that what you think it should be?
So there are two aspects, just very quickly. One thing is actually, making itself, like the core of CK framework, more professional, I would say, more standard. Second aspect is about automations, because this is separated. So automations, we need to start providing standards. So again, this was, Lego bricks, but you can have thousands of Lego bricks. And that is a big second step where I'm collaborating with ML Commons, with ACM, and CK provided it bootstrapped this activity that we're trying to standardize those Lego bricks, where basically from those Lego bricks, you can build portable solutions for end users.
Thank you so much for your time, and I wish you all the best in the future.
Yeah, thank you, Peter. It was really great. Thank you for having me, and I hope it will be fun and useful for the community. If someone is interested in this work, it's a community effort, please get in touch.
I hope this interview gave you a flavor of what you could do to evaluate your machine learning application and take it to production. And as per usual, you'll find links to Grigori's website, partner websites, and the GitHub repo of the framework in the episode notes. And with that, goodbye.